Welcome to G Fun Facts Online, where we unpack the science and technology shaping our future. Today, we're diving into a concept that sounds like it's straight out of science fiction, but is very much a reality. Imagine a world where you could test a skyscraper's resilience to an earthquake before a single brick is laid. Or where a surgeon could practice a complex operation on a perfect virtual replica of their patient before ever making an incision. This isn't a movie plot, it's the world of digital twinning, a revolutionary technology creating virtual replicas of the real world to predict the future and unlock incredible innovation. So what exactly is a digital twin? Think of it as a dynamic virtual model of a physical object, process, or even an entire system. It's not just a static 3D model or a blueprint. It's a living, breathing digital counterpart that is constantly updated with real-time data from sensors attached to the physical object. This constant stream of information allows the digital twin to perfectly mirror and simulate the behavior of its real-world counterpart. This gives us invaluable insights into its performance, its health, and even its potential future. And if you're wondering if this is just some niche tech, the numbers tell a staggering story. The global digital twin market was valued at nearly $9 billion in 2022. By 2030, it's projected to soar to over $137 billion, with some estimates reaching as high as $259 billion by 2032. That's exponential growth, fueled by this technology's power to bridge the physical and virtual worlds. The idea first popped up in 2002, introduced by Dr. Michael Greaves at the University of Michigan. But it was the recent explosion of other key technologies that really brought it to life. Think of the Internet of Things, or IoT, providing the countless sensors needed to collect data. Then there's cloud computing, which gives us the power to store and process all that information. And finally, artificial intelligence and machine learning provide the brains to analyze it all. So how does this symphony of technologies actually work? Let's break it down. First, you have the sensors and IoT. These are the eyes and ears of the digital twin, constantly gathering data from the physical world, everything from temperature and pressure to location and vibration. Second, this data is fed into a detailed virtual model. This model is integrated with the real-time sensor data, as well as historical data and original design specifications. Third, you have artificial intelligence and machine learning. These are the brains of the operation. AI algorithms analyze the vast streams of data to identify patterns, predict future behavior, and provide actionable insights. They can spot tiny anomalies that might signal a future failure or find ways to optimize performance. All of this is powered by cloud computing, which handles the immense data storage and processing required. And finally, virtual and augmented reality can provide immersive ways to interact with the digital twin, letting users visualize complex data in a much more intuitive way. Now, you might be thinking, isn't this just a simulation? That's a great question, and there's a key difference. A traditional simulation usually studies one specific process with a fixed set of data. It answers the question, what if? A digital twin, however, is a dynamic environment that's constantly updated with real-time data. It has a two-way connection with its physical counterpart. It doesn't just show what could happen, it shows what is happening right now. The applications for this are transforming industries across the board. In manufacturing, companies use digital twins to optimize production lines and predict equipment failures, sometimes improving the quality of parts by 40%. In healthcare, doctors are creating personalized digital twins of patients to plan surgeries and test treatments in a completely risk-free setting. Entire cities are getting the digital twin treatment. Singapore, for example, created Virtual Singapore, a detailed 3D model of the entire city to help with urban planning, traffic simulation, and disaster management. The automotive industry is all in, with companies like Tesla creating a digital twin for every single car it makes, collecting data to improve performance through over-the-air updates. In aerospace, SpaceX uses digital twins to optimize rocket designs, And the US Space Force is even creating a digital twin of space itself. Of course, with great power come great challenges. Implementing this tech isn't always easy. There are concerns about data security and privacy, the high initial investment, and the challenge of integrating it with older systems. There is also a growing need for skilled professionals who can build and manage these complex systems. So what's next for digital twins? The future is incredibly bright. We're heading towards AI-driven autonomous twins that can make decisions without human intervention. Well, see more twin-as-a-service models, making the tech more accessible. And, well, see interconnected ecosystems of twins, creating virtual models of entire supply chains or cities. Digital twins will also be a foundational part of the industrial metaverse, creating immersive, collaborative, virtual environments. In conclusion, digital twinning is far more than a buzzword. It's a paradigm shift, fundamentally changing how we design, build, operate, and maintain things in the physical world. By creating a seamless bridge between the real and the virtual, this technology is unlocking a new era of innovation and data-driven decision-making. As the lines between physical and digital continue to blur, the potential for digital twins to reshape our world is truly limitless. That's all for today on Fun Facts Online. Thanks for listening, and stay curious.